In 3, 2, 1, go.
Will always have it. I'll be on deck. Keep it in check. When you need that, I'ma let you have it. Beats in the drum like Dum Diddy Day. I like the dirty rhythm you play. I wanna hear you calling my name like, hey mama, mama, hey mama, mama. Banging the drum like Dum Diddy Day. I know you want it in the worst way. I wanna hear you calling my name like, hey mama, mama, hey mama, mama.
Hello and hi, my name is HAZWANI binti Muhammad Zaini. Today we are going to see a very interesting topic which is hypothesis test involving single mean. Firstly, single sample test concerning a single mean which is variance known. Before that, I want to remind you a certain thing, population and sample. For population size is capital N and sample size is small n. For population mean is mu and sample mean is x bar, and also population standard deviation is sigma and sample population is small n. So these things you need to remember because whatever is given in problem, you need to write in this term. In step 1, we set up our hypothesis. This is almost identical to one population proportion except that the notation changes to reflect that we are now talking about a population mean. Our null hypothesis will always be the equal. Either we have and our null hypothesis H0 and H1 alternative hypothesis. Generally, H0 is mu equal to mu naught and H1 is maybe mu naught equal to mu naught or mu less than mu naught or mu greater than mu naught. These three possibilities called two-tail test. This called single tail, this is left tail and right tail. From this point, we will rarely conduct one-sided test in this course, but we will still briefly discuss the concept here. When we setting up hypothesis, be sure to not use any information about the sample data collected to help you choose the correct alternative hypothesis. Use only the information about the research question of interest to make this choice. Step 2. Level of significance should be 1 or 2%. Step 3. Find the p-value of the test statistics. We need to find probabilities to the left for less than test, to the right for greater than test. Probabilities on both tail for not equal to test. Step 4 is calculated value and table value, which is if p-value less than equal to 0.05, then we reject H0, and the conclusion is there is enough evidence that H1 is true. And if p-value greater than 0.05, then we fail to reject H0, and the conclusion is there is not enough evidence that H1 is true. This is the formula for hypothesis test involving single population mean. The formula is Z equal to x bar minus mu naught divided by sigma and divided square root of n.
Hi, Assalamualaikum and a very good day to everyone. My name is ALLISSA binti MAZLAN. You can call me Miss ALLISSA, and today I'm gonna show you how mean can be used in real life situations. The mean is the average of the observation. Let's say if you want to make a survey to determine how many students are left-handed in education of mathematics, you don't have to collect data from each of the students in education of mathematics. You just have to collect data from several students randomly as a sample, and just find the mean of the data. So, in a group of large population, you don't have to collect data from each things in the population. Instead, you can collect data from the sample of the population, maybe 50 sample out of 100, or maybe 100 sample out of 1000. But remember, mean is just an estimation. It cannot be 100% accurate. The only way to have a 100% accuracy rate is to survey all the 1000 students in the population, which will be possible but impractical. So mean is widely used in daily life, even in school. Have you noticed that your final grade you get in a subject is usually a mean? So basically, this is the classic type of average when your overall performance on many items is evaluated with a single number. So this mean represent the total number of points you scored in the class divided by the number of possible points. So that is how teachers determine your grade score. Next, if you work as an insurance analyst and actuaries in the healthcare industry, you will use mean to calculate the mean age of individuals you provide insurance for, so that you will know the average age of your customers. And if you become a real estate agent, you will have to use mean in calculating the mean price of houses in a particular area, so you can inform your clients of what they can expect to spend in a house. Besides, if you work in human resources department at a company, you can also use mean to calculate the mean salary of individuals in a certain field in order to know what type of average salary you can offer to the new employees. But if you work in a marketing department, you will also need to use mean to gain an understanding of how your advertisement perform. You can calculate the mean revenue earned per advertisement, so you can analyze which platform work best for your ads and how much money your company is making on each ads. So generally, mean is usually used in a company. If you are not going to work as an insurance analyst or a real estate agent, you might work in a company in the future. So, you will eventually use mean in your life. Let's say, when you work in a company on a certain position such as financial department, your boss decides to give an extra 5% wage to the employees. So you have to find how much your company would cost in order to give each of the workers a 5% wage increase. This can be done if we only know the mean wage of the company and the number of employees. Since the mean is just the total value divided by the number of data points, the total cost at a 5% wage increment for all workers sums up to 5% of the mean multiplied by the number of the workers. It's as simple as that. So mean is actually important because it gives us the idea to estimate the center value of dataset. That's all from me. So for the next part, I will pass to the next presenter, Miss Fatin.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin NASUHA binti Muhammad Nazri. So I will proceed with the question about hypothesis test involving single population mean, which variance known. As you see, the question says boys of a certain age are known to have mean weight of 85 pounds. A complaint is made that the boys living in a municipal children's home are underfed. As one bit of evidence, n is equal to 25 boys of the same age are weighted and found to have a mean of 80.94 pounds. It is known that the population standard deviation is 11.6 pounds. Based on the available data, what should be concluded concerning the complaint? Use 0.01 level of significance to test H0, which is mu equal to 85 pounds against H1, which is mu not equal to 85 pounds. Assume the population to be at least approximately normally distributed. First of all, for the solution, first step, we need to setting up the hypothesis, which is H0 is mu equal to 85 pounds and H1 is mu not equal to 85 pounds. Next, for step 2, stating the test hypothesis as shown. In this question, we use Z test as the variance known. Step 3, using A equal to 0.01 to find the critical region. From a normal distribution table, Z A over 2, which is Z 0.005 is equal to 2.58 and negative Z A over 2 is equal to negative Z 0.005, which is equivalent to negative 2.58. Next, step 4 is computation. Under H0, mu is equal to 85. So, by using the formula, substitute the value of sample mean with 80.94, mu with 85, population variance with 11.6, and lastly the value of n with 25, and we got the answer negative 1.75. Lastly, step 5, decision and conclusion. Since negative 1.75 is greater than negative 2.55, so we fail to reject H0 at 0.01 level of significance. So, the mean weight is equal to 85 pounds. That's all from me. Thank you.
Hi, today I want to do some example question related hypothesis test involving single population mean when variant unknown and sample size is more than and equal to 30. Before I explain how to solve the question, let me read the question first. The question is, past experience indicate that the time for high school senior to complete a standard test is a normal random variable with a mean of 35 minutes. If a random sample of 35 high school senior to an average of 33.1 minutes to complete this test with a standard deviation 4.3 minutes. Test the hypothesis at the 0.1 level of significance that population mean equal 35 minutes against the alternative that population mean less than to 35 minutes. Let me explain the step when solve this question. To solve this question, we must use 5 steps. Step 1, which is setting up the hypothesis. First, hypothesis null, which is population mean equal to 35 minutes, and alternative hypothesis, which is population mean less than 35 minutes. Step 2, stating the test statistic, use formula test equal to the sample mean minus population mean as stated in the hypothesis, divide the sample standard deviation per square root sample size. Step 3, which is using alpha equals 0.1 to find critical region. From the normal distribution table, we get value of Z critical, which is negative 1.6449, but before you get this value, you must divide Z alpha, which is 2. Step 4, which is computation. Under null hypothesis, which is population mean equal 35 minutes, this step we enter the value given in the question into the formula, which is 33.1 minus 35 divide 4.3 per square root 35, and we get Z test, which is negative 2.6141. The last step, which is step 5, we make decision and conclusion. Since negative 2.6141 less than negative 1.6449, so reject null hypothesis at 0.1 level of significance that the mean for high school senior is less than 35 minutes. That's all explanation to solve the question. So, I want to pass to my friend to explain question related hypothesis test involving single population mean when variant unknown and sample size less than and equal to 30.
Hello everyone, my name is MASYITHAH HALWANI binti JOHARI. I will continue with my part, which is hypothesis test involving single population mean, where variance is unknown and n is less than 30. Okay, let us try to answer this question. The specifications for the production of a certain alloy called for 23.2% copper. A sample of 10 analyses of the product showed a mean copper content of 23.5% at a standard deviation of 0.24%. Can we conclude at 1% significance that the mean copper content is higher than the required specifications? Assume that the copper content is normally distributed. First of all, let us take out the information that have been given. 23.2% copper is for our hypothesis and 10 analysis is our N. 23.5% is the mean and 0.24% is the standard deviation. And lastly, 1% significance is our alpha. The question is to know the significance that the mean copper content is higher than the required specifications. So, the symbol is bigger than. As we can see, we don't know our variance and our N is 10, which is less than 30. So, we use case 3 hypothesis test for single population mean. To answer this question, there are 5 steps we need to follow. First step, we need to set up the hypothesis of the question. Our H null is mean equal to 23.2 and H1 is mean bigger than 23.2. Second step, we need to stating the test statistic. In our case, we will use t-test. Next, using alpha equal to 0.01 to find the critical region. From a normal distribution table on table 7, we get the critical region is 2.821. Step 4, computation. Under H null, mean equal to 23.2. So, the test statistic is 3.95. Last step, decision and conclusion.
Since the test statistic is 3.95 bigger than 2.8 to 1, so reject has null at 0.01 level of significance. That the mean of copper content is higher than 23.2%. Okay, that it is all from me. Hopefully you can understand regarding this question.
In conclusion, the main purpose for conducting a hypothesis test of a population mean is to make decisions or judgments about the value of a parameter, such as the population mean. We use it to accept or reject a null hypothesis. Hypothesis testing is used to infer the result of a performed hypothesis performed on sample data from a large population. On sample data from in hypothesis testing, an analysis tests a statistical sample with the goal of accepting or rejecting a population or a null hypothesis. The test tells the analysis whether or not his primary hypothesis is true. If it is true, the analysis formulates a new hypothesis to be tested, repeating the process until data reveals a true hypothesis.